Hi everyone, so this week in lab we're going to cover diffusion, osmosis, and transport. Some of the chemical conversion questions that we're going to see in lab, I just wanted to go over them because it's good to have like a good background with converting chemistry, things like that. So let's start. The example that's worked through is 4 grams of sodium chloride salt per deciliter, basically. So this is going to cover how to get between metric liters, how to do conversions between moles, all that. So let's just cover the 3 grams of sodium chloride that the example is right below, and you'll be expected kind of in lab to try that one. So this is going to prepare you for anything you might see on an exam, test, things like that. And it's also good to be able to do this math and convert in between different chemicals, things like that, because you never know what you're going to have to kind of infuse in a patient or one of your clients, things like that. You want to be able to know how to regulate, basically how to regulate the body and how you can change that, like we talked about with medicine being the way that we change physiology. So to start, and I'm going to do the conversions the way that I was taught. Hopefully that same notation is going to follow along with how you guys do it. I'm going to do step by step, and then I'm going to do the whole thing out in one stretch if you want. So step by step, let's just start. We are given 3 grams of this sodium chloride, and that is per deciliter. Okay, so step number 1, and I'll have to erase the steps as we go, but you can pause and write as we go as well. So to do your basic conversions, I use the table method, which is going to allow us to just multiply and divide and really guide all that. So, but step by step, first thing you can do with the table method is basically put your similar unit up here that you're going to convert from, so deciliters, and I want to convert to liters, okay? So in this case, per liter, there's 10 deciliters, okay? So that's our first step, is that we have to get to liters so that we can get to molarity, because that's moles over liters. So this is that step that you do, basically. So in this case, you have deciliters over here. There are 10 of these deciliters per liter. So you can cross out that notation. What that's doing is basically causing this equation and this amount to be now expressed in terms of grams per liter right here instead of grams per deciliter like we had over here. So now we can multiply anything on top of the conversions. We're going to multiply, go here. So the solution is actually, when you change the notation, it's 30 grams per liter in that case. So in a liter, since it's bigger, it makes sense that the same conversion is going to have like a higher number when you're notating things, right? Okay, so we can go to step 2. So we have 30 grams per liter. And what moles allow us to do is convert grams more towards like a concentration, like sort of a number of molecules in a solution. So it's more of like a concentration that we can get. So in this case with grams, we have to use the molecular weight of our sodium chloride to convert. So we're going to go from grams to moles. So 1 mole of sodium chloride, salt, remember, is equal to this right here. Just like this conversion, 10 deciliters is equal to 1 liter, we can convert the math just using this cross method. So now instead of grams, we now have 1 mole of sodium chloride over liters. See how every time you cross one out like this, you can basically change your conversion. So in this case, we have moles over liters. So doing the math here, we're going to find 0.518 moles per liter. And so anytime you write just the L, that just means there's 1 liter in there, so that's okay. So what happens, just like up here, if you have something that you're multiplying by, it's going to be on top, for example, just based on the way that you did the conversion. So just like over here, in this case, if we're converting grams, grams has to go down here. Its equivalent value, the 1 mole, has to come up here. And if we're canceling grams, you can go through this and you have to divide anything that shows up on the bottom. So you start by multiplying everything on top and then divide by the numbers that are going to be on bottom. Okay. All right. So now we are at this stage. We have, 0.518 moles over 1 liter. And remember, this is the same exact value that we started all the way in the beginning with, the 3 grams of sodium chloride per deciliter. We've just now converted it to these new values that we can basically transfer into, into something more useful. Okay, so here's where osmolarity starts coming up. So for every mole, for every amount, basically, a mole is kind of like a dozen, but in this case, it's a lot. It's Avogadro's number of molecules that equal that many grams. 1 mole of sodium chloride is actually 2 osmoles of sodium chloride. And the reason for that is that osmoles measure the number of particles that show up in water. So because sodium chloride is basically just 2 molecules being held together by their opposite charges, see them here, in an ionic bond, this is actually going to be 2 different molecules dissociating. It's not one. They don't really stay together in water. So in this case, we can go from moles times 2 to 2 osmoles. And really, so this step is probably one of the most confusing, but all osmolarity conversions are doing is showing that there's 2 particles that in this compound that are going to show up in water. Because in water, so say you have, a piece of water right here, not that a thing like that exists, you have sodiums and chlorides that are kind of existing on their own. They're going to be hydrated by small water particles completely on their own. They're not going to be connected. That's why you need to have the 2 here. So in this step, we move on, and it is about 1.03 osmoles over, and we're still at 1 liter. We didn't touch liters yet. So in this case, we can do this step, so 0.103 osmoles over 1 liter. Because remember, we're still keeping this volume constant while we're doing the conversion. And to measure the way that we're doing it, most things are measured in milliosmoles. So remember, milli equals 1,000 times smaller than standard. So you can do the same thing here by making milliosmoles. So 1 osmole of whatever we're measuring is going to be equal to 1,000 milliosmoles, because in this case there's going to be a lot higher concentration because we're looking at a lot smaller unit, because remember, this unit right here is 1,000 times smaller. So in this case, multiply this by 1,000 and you end up with a number that looks like this. Per liter. So in this case, you really don't need to, look at, you don't really usually need to look at the liter here because it's already still implied back here because we never changed it. You can mess with it in more advanced chemistry, but for our purposes, now we can just look at this number right here. So our cell, so this is the concentration of the solution. And here's our cell, which is actually at 300 milliosmole. So in this case, the concentration of this salt is way higher, so there's tons of Na molecules, right? And essentially what the water inside the cell is going to do, because there's a lot more salt out here, it's going to leave the cell to try and meet this sodium out here and hydrate it and even everything out. And that means that the cell itself is going to shrink, because this solution, and remember we're measuring the solution outside the cell, is hypertonic. Okay. So in that case, this is how you can measure and convert between a few things. So let's, for the final thing, let's go through the whole thing and I'll kind of show you how to do the table, kind of the table conversions all at once, okay? That's why I'm wearing the gloves, is because I don't have an eraser in here, so. This is my best, the best I got for today. All right, so to begin, we started with 3 grams Sodium chloride. This was in 1 deciliter. We're going to convert that from deciliters to liters, okay? At the same time, now we're going to look at converting grams to 1 mole. So in 1 mole, they're equal 58.5 grams of sodium chloride. Now remember, that's going to change based on the molecule that you're measuring, right? Like glucose is 180, I believe. So it's different. So now we're here. We've converted grams to moles. So now we're moles over liters in this case. Per each mole, there are 2 osmoles because there are 2 molecules that are going to show up in water that are actually going to get separated. And that per 1 osmole, there are 1,000 milliosmoles. Okay? So that's the whole thing. So in this case, you canceled out moles here, you changed them to osmoles. You changed out osmoles for milliosmoles. So your true answer is something, and the big number, that 1,010 or the 1,030 number we got, this is over 1 liter. And again, you don't always need to write the 1. It's implied that it's just 1. And so that's kind of your full thing. The way that you can do the math is we would take 3 times 10 times 1 times 2 times 1,000. So you get that whole number, and then you divide it by each number successively in here. Divided by 1, it's the same thing. Divided by 1, same thing. Divided by 58.5, that will cut us down in that case. Divided by 1, divided by 1. So if I did that math right here, you still end up with this answer. So you can do it step by step, like the first way, or if you feel more comfortable in your conversions, you can just do the whole thing all at once. So this is definitely something that takes some getting used to. One thing I should remind you is that it's kind of like driving. The car doesn't control you, you control the car. Similarly, in this case, you control the equations. The equations do not control you. So don't be afraid of them. They're there to help, you know. So flag me down if you need any help, email me, things like that. This should be pretty reminiscent of chemistry, which is a prereq for this class. But if you do want some more refresher time, just email me and we can find a time.